I'm here at AMD's Mile High Design Center, and we're going to take a deeper dive into the new R-Series and talk a bit about performance. Could you tell us why this new chip is going to have better performance than the ones in the past?
Absolutely. I can go through quite a few of the advanced computational abilities. First, I want to focus on the core, so let's talk about the core.
Okay, perfect.
One of the big advances is the floating point unit, which brings the floating point multiply accumulate functionality to the central processing unit for the first time in the embedded market. That has huge advantages because it allows you to do a floating point multiply and add as one single operation for only incremental power versus just a multiply. Classic implementations had a multiply and an add separately, and so by fusing those together, it's a lot more power efficient.
Now, this is also an operation that's typically found in DSPs.
That's exactly right. Not only is it found in DSPs, it's found in the GPU and has been in the GPU for a long time because it's so much more efficient at computational throughput.
Now, this system does have both the processors and the GPUs. Can you tell us how these two actually are going to be able to work together?
Absolutely. So the processor is really focused at low latency operations that are very control dominated, and so we focus on the minimum latency. So the floating point unit in the central processing unit has very low latency, and versus the graphics processing unit has higher latency but much higher throughput. So just to put a couple of numbers behind that, if we take a typical case of the central processing unit running at 2.4 gigahertz and the graphics unit running at 600 megahertz, the graphics processing unit gives you roughly 500 gigaflops of single precision performance versus approximately 70 to 80 in the central processing unit. So you can see the tremendous advantage the GPU gives you if you can take advantage of it. So
are there any changes to the instruction set?
Yes, the R-Series actually brings several new instructions for the first time. Those include SSE 4.1, SSE 4.2, which help a lot of media and string type operations, and advanced encryption is done in hardware now, which can provide up to a 10x improvement in throughput of certain encryption applications, which are very common.
How about on the GPU side? Have there been improvements or changes there?
Absolutely. So we've had the video decoder for quite a while, and it's improved quite a bit on the R-Series versus past generations, and for the first time we actually have a hardware video encoder which can encode video faster than real time in hardware very efficiently.
So designers can now do trade-offs on the GPU, so they could either be doing computation or being used for display purposes.
Exactly. So one of the big advantages of AMD's heterosystem architecture is to allow folks to be able to take their computationally heavy applications and leverage the immense power of the graphics processing unit to really accelerate their applications and achieve things that they never thought was possible with that immense horsepower.
Well, also talking about power dissipation is going to be an issue. What about balancing the performance of the two computational units, the GPU and the processor?
So it turns out that based on the code that you're running, the core is able to balance the power to where it's needed. So if you want to use the central processing unit floating point unit, that will get the power. If you want to use the GPU's processing power, that will get the power. The power is allocated to whatever can do the computation most efficiently.
Well, great. Thank you for telling me about the architecture. It gives me a much better insight on what you can actually do with this chip.
Thank you.